In this video, we'll talk about abstraction. So we'll divide this into two sections. The first section will talk about what is abstraction and how do we implement it. And the second section will be why do we even need it? Okay, because it's easy to understand abstraction. It is easy to understand the way to implement it, maybe in different languages, but we'll stick to Python here. But it's difficult to understand why do we need it. So we'll need a separate section on that. So let's start with what is abstraction. So abstraction basically means hiding the complex implementation from the user. Okay, that's what abstraction is all about. So just to give an example, let's say if you drive a car. Of course, car has multiple components, right? So we got an engine, we know how the braking system works. So we got brakes, clutch, accelerator, then we got gear. So we have all these components, right? And because of this, your car moves. Now, the most important part here is the engine. But when you learn to drive, you don't have to know how engine works. Of course, it's good. It's a good knowledge, and a lot of people love understanding how engine works. And I got to know that a bit later. But the point is, when you are learning to drive, you don't have to understand how engine works. What is important for you is that steering, that those three things, ABC, and the gear. So important is, here what we are doing is we are doing abstraction. So we are hiding the complex implementation from the user. Okay. The advantage is, let's say in future, you are learning to drive one car, which is, let's say, EcoSport, the Ford EcoSport. I love that car. And now you know how to drive that car. Maybe you also understand how the engine works of that particular car. And then you are going for a different car, and different car will have a different engine. Maybe this time you are driving a V8 engine, and that's my dream to drive that once. But let's say if you have that V8 engine there and you got a car, you can still drive it, right? At least basically you can start it and you can drive it. You don't have to understand how engine works, right? So you are basically hiding that structure. So for you, what is important is the interface which you see in front of you. So that is abstraction. Now, the way you can implement that is we have a concept of interfaces and implementation. So what you do in the interfaces, you define or you declare what are the things needed to build a car. Maybe you need a steering, you need an engine. So you can declare those things. As a user, you are only focused on the interface. Mind you, in the interface, we are not implementing anything. We are just saying, this is what it should do. And then you implement it. Now you can do that in a class, right? So, and we have seen that, right? In a class, you create variables, you create methods, or you can call it functions. So you create everything in a class, but in the interface, you just declare them and you implement that in the class. And you are basically hiding this class from a user. So as a user, I'm just going to focus on the interface, but yes, at the runtime, you are going to use the implementation. Now, just to give an example, and let's go back to the override example which we have done. Even if you're creating the object of B here, as you can see, we can still refer that as an object of A because A is inherited by B, right? What if you declare this? What if you don't define the function here? So let's say you have a function show, but you're not defining anything there, but still you are implementing it. So this can be our interface where you're not defining anything, you're just declaring it, and this is your implementation. In this example, we have implemented both, but let's say I'm just giving you a situation. This is what you can do, but how will you do it? That's a question. So let's understand how do we do it? And then next part, we'll talk about why do we need it. So it's actually simple. What I'm going to do is I'm going to create a new file here inside the OOP, which is abstract demo.py. And in this, I'm going to create a very simple class. Maybe we'll try to implement this only A and B. So let me create a class called A. And in this class, let's say I have a function called show, and we'll pass self here. And I'm not doing much here, so I'm just saying print A show, okay, in A show. Simple. Now, what I want to do is, of course, for this particular class A, I can create the object, and that's the main use, right? So if I say obj1, and A, I can of course create the object of it and I can call that particular function. There's no problem in that. I will just try to run this. So it's Python abstract demo.py. And you can see it says in A show. Now I want to achieve abstraction. Okay, so to do that, we have to basically build the interface first. And the way you can do that in Python is with the help of abstract classes. Okay, and to write an abstract class, we need to have abstract methods. So this class need to be an abstract method, and this class need to be an abstract class. Now, how will you do that? See, there are different ways in to do that in different languages. In Python specifically, it was not built for OOPS. Python was built for functional programming, and OOPS came later. To do that, they had to build a particular module using which you can do that. And that module is called ABC. Okay, I know, weird name. It's not accelerator, brake, and clutch. It's abstract base classes. Okay, why abstract is because you want to make it abstract. You don't want anyone to create object of it. Why base is because someone else is going to inherit it. And classes because they are classes. We don't have the interface keyword in Python. So we'll say from ABC, and what you have to import is ABC class. Yeah, that's right. So package name is ABC. The class name is also ABC. This time ABC stands for abstract base class. And apart from this, you need one more thing, which is the abstract method. Okay, so you need to do these two things, the ABC class and the abstract method. Now, once you have that, how will you make the object and how will you make an abstract class? Now, just by importing them, of course, it's still going to work. Now, I don't want it to work. It's because there are certain properties. The first property is you cannot create object of the abstract class. Here, we are able to do that. Second, abstract method should be a part of the abstract class. And this class is not an abstract class yet. And if you want to create abstract method, you cannot define it. There should not be any statements. So these three things you have to remember. So I want to stop the object creation. Now the way you can do that is by inheriting the ABC class. And that's it. This is how you make an abstract class. I know you don't trust me and you should not be trusting me. So there's one more thing left is in this class we need abstract methods and we don't have that. The way you can create an abstract method is just on the top of the function, just write a decorator abstract method, and we need to do one more thing. Since abstract method don't have the implementation, we can write pass. We can't keep it empty, unfortunately, so you have to say pass. And now if you run this, you will get an error. It says cannot instantiate the abstract class A without an implementation for abstract method show. Okay, so since you don't have the implementation for this, you can't create object of abstract class. So this is how you can achieve abstraction. But I know still doesn't make any sense. It's because we are not, why do we use it, right? If you can't get the object of it, why in this world we are creating a class and then doing all this stuff when you can't create the object, when you can't call it? To make it more sensible, let's use another example in the next section. Now, what we are going to do is let's remove everything. Now we know how abstract class works. How to create an abstract class, how to create abstract method. Let's take another example. And this time, let's take example of a payment gateway. See, whenever you build an e-commerce application, this can be for courses, this can be for a product by, let's say, Amazon, Flipkart, or maybe courses like Telusko. So what you can do is you can basically have a payment gateway. So if I want to sell my courses, I need to integrate the payment gateway. But then which payment gateway I should use? So let's say if I'm building an e-commerce application, of course I can choose one payment gateway. And for that particular payment gateway, I can write a code. So there's my application, there's my payment gateway connected. So they are tightly coupled. Now in future, if that payment gateway is not agreeing to my terms, or maybe they have changed something which I'm not happy with, what should I do? Of course I have to change my payment gateway, but then should I write a separate code base for that since I'm changing my payment gateway? Of course I can, but then does it make sense to change the code base just if you're changing a payment gateway? So if you're tightly coupled with your payment gateway, then that's an issue. What if you can say, let's do plug and play? So now I'm using, let's say, Razorpay. In future, if Razorpay has some issues, I can use Stripe, I can use PayPal. That switching should be easy. How will I do that? So let's say I have a class called purchase. This is where, or you can say a page where you can do checkout. So we got this purchase class. In this, I have a particular function called checkout. And of course, in checkout, there should be multiple information about the products, or maybe I can pass a cart. In this cart, I can have different products and different pricings. But let's keep it empty. And the only thing I'm going to pass here is self. Now in this checkout, I'm going to print checking out. We are not here to learn about payment gateways. We are here to learn about abstraction. So let's keep it simple. So checking out, and of course there should be a payment gateway. So what I want is I want an object of a payment gateway. So I will say gateway dot pay. Okay, this is what I want to achieve. So when someone says checkout, there should be a payment gateway and I should be able to pay for it. But if you observe, we don't have the object of gateway. So what you can do is you can use init to initialize the object. And unfortunately, this is not an inbuilt object, the payment or the gateway here. So what I can do is I can accept gateway and self.gateway is equal to gateway. Okay, so the thing is, I need to pass the gateway object. Then only I can do pay. Now, one thing you can do is you can be very strict here. You can do a tight coupling. So let's say I have a class called RazorPay. And let's say that's my payment gateway which I'm using. And RazorPay says I have this method called pay. And in this, I can print paying using RazorPay. And of course, this video is not sponsored by RazorPay and they should sponsor me. So let's say I got this class, I got this method or function pay, and then I'm saying paying using RazorPay. And of course, to actually make it work, you need to create object of payment gateway. So I will say gateway 1, and this will be from RazorPay. Then I will create object of purchase. So let's say purchase, and this will be object of purchase. And now, with the help of purchase, I should be able to check out. And then checkout says, pass me the object of payment gateway. And I'm doing that now. So simple, right? Nothing fancy. Normal classes, normal implementation is just that the gateway or the purchase is dependent on the gateway. And if you're making it very strict, you're basically saying this is tightly coupled. So let me run this, and it says, okay, there is an error. It says one positional argument missing is because I should have been passing gateway here and checkout. Okay, why I'm passing gateway in checkout? My bad. So let's run this and checking out paying using payment gateway. Everything works. Okay, so I built an e-commerce website and I'm able to pay for it. Okay, the problem is in future, if they decided, hey, I want to go with some other name. So, or I want to go with different implementation, I'm stuck. So what you can do is you can define certain properties, right? So every payment gateway should have this particular function called pay. Otherwise, this will not work. Example, let's say if they decided to go and rename it to pay, and I will get an error now because then I have to change my code base based on their code base. So example, let's say we got one more payment gateway here, which is let's say Telusko pay. We should build our own payment gateways. And they are good. They are using pay as a name. They are good because that's my company. And I'm going to say, now of course, RazorPay will not going to sponsor me for this. Okay, so I'm using pay here. Now, when you pass the object of RazorPay, now RazorPay don't have this PAY, they got PE. So it should give an issue. But the moment I'm passing an object of Telusko, so let's say I'm saying gateway 2, and this will be Telusko pay. I'm going to different gateway now, and I'm going to pass 2 here. Let's run this, and you can say paying using Telusko pay. So it works with this. Now there are two things. One, I want to maintain the standards. When I say payment gateway, it should have this function called PAY, not PE. Second, why a purchase or the e-commerce website should stick to the object of RazorPay or the Telusko pay. There should be some standard, some default interface, and I should be using that interface. So the way you can do that is, because see, when you specify the type here, and if you are very specific, hey, I'm going to accept a RazorPay object and I'm passing Telusko, let's see, it still works is because that's how your duck typing works or polymorphism works. But I don't want to be very specific here that I'm going to pass RazorPay. So what you can do is you can use a standard class, and that class would be payment gateway. And this payment gateway should have a function called pay. And the beautiful thing is I'm not going to pass anything here. I'm not going to have any statements there, just pass. And this class, I'll make it as ABC, abstract class. Why? It's because I don't want anyone to create object of a payment gateway because it's just a concept. The actual implementation is Telusko pay and RazorPay. And this particular function will be an abstract method. Now, you can make it compulsory for all the classes to inherit the payment gateway. Where you can check that. So let's say when you accept this object, you can actually check which type of instance this gateway is. If that instance is of type payment gateway, then only accept it. Otherwise, don't accept. So how will you know that's a type of payment gateway? Just by inheriting it. So it becomes compulsory now for them to have this method which is pay. So now let's say if I'm passing gateway 2, so you can see we got an error. It says abstract class RazorPay, we can't instantiate it is because there's an abstract method called pay. So now we know there's a problem. So we can, for the standards, and we can say pay. There can be another function here, which is PE, your choice, but pay need to be there. And that's how you can maintain a standard. So every payment gateway should have this particular function. So you can have an interface by saying, if I have a steering, there should be some implementation. If I have a gear here, there should be some implementation. So that's abstraction. And how do you implement abstraction is with the help of abstract method and the abstract class. So that's it from this video. See you in the next part.